All right, we are going to learn a little bit more about I today and understand that I can be simplified. There's a pattern that's going to develop as we do this, and then we can use that as we move towards doing other problems with imaginary numbers. So let's develop the pattern. I is I. No matter what way you put it, I is just I. However, yesterday we did define I to be the square root of a negative 1. So we're going to use that to help us figure out what I squared is, which basically means that if I is the square root of negative 1, but we're going to square it then, that means we have a square and a square root, and they actually undo each other. So it turns out that I squared is actually equivalent to negative 1, which doesn't even have an I in it anymore. We're going to use this concept of I squared being equal to negative 1 to help us find the rest of them. So I to the third is the same. If I were to break it down into two different parts, I to the third is the same thing as I squared times I. Well, if we just learned that I squared is negative 1, that means we really have negative 1 times I, which is just negative I. So let me highlight as we go along what each one actually is equivalent to. So let's move on to I to the fourth. I to the fourth is I squared times I squared. And we just learned that I squared is negative 1. So that means I have negative 1 times negative 1, which is actually 1, which is even nicer than negative 1. I like 1 better than negative 1. But if you notice, your even powers of I, when you simplify them, don't even have an I in them anymore. But your odd powers of I still have an I. Okay? We're going to see what that does as we continue on here with some of our powers of I. I really liked I to the fourth because that got us down to 1. So when I start breaking down the bigger ones, I'm going to break them down with an I to the fourth. So I to the fifth is the same thing as I to the fourth times I, which is really 1 times I. So that's really just I. I to the sixth is, I don't know why I wrote a negative. I to the sixth is I to the fourth times I to the second. I to the fourth down here is 1, and I to the second is negative 1, which means I to the sixth is the same thing as negative 1. I to the seventh can be written as I to the fourth times I to the third. I to the fourth is 1. I to the third is negative I. I'm going to get negative I. So then I have I to the eighth is I to the fourth times I to the fourth. And I get 1 times 1. And that's just going to be 1. So if I look at what I have highlighted, hopefully you see that I is like I, negative 1 is negative 1, negative I and negative I, and 1 and 1. And just pretty soon here you're going to start to see that we develop a pattern. And that pattern will continue, is 4 long. It goes I, negative 1, negative I, 1. I, negative 1, negative I, 1. And that's going to keep on going. So it turns out that regardless of whatever your exponent is on I, we can simplify it down. And if you notice your answers, they're either 1 or negative 1, or they're I or negative I. So never do you see a power or an exponent on I. It can always be simplified. So what do we do with this? I wrote the pattern here so that we have it fresh in our minds. And what you have to understand is you're looking to see kind of actually how far into the next pattern you go. And what I mean by that will be discovered in this first one. So I to the 17th. If I were to write, it'll take a while, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 I's. So what you'll notice is the pattern repeats every 4. So here's a pattern that's completed. Here is a pattern that is completed. Completed pattern. Completed pattern. So what we're looking and what we need to understand is you're really looking to see at what point into the next pattern are we? And that actually is really the remainder. So if you have I to the 17th, we all have a remainder. We're going into the next pattern. So that means that you have the same, or it's equivalent to I to the first, which is really just I. So to find out any other exponents on I, we're going to go back to elementary long division to figure out what the remainder is so we can see where into the next pattern we've ended. So if you remember anything about long division, you're going to take your exponent that you have. Our pattern is 4 wide. So you see that we have 4 things. So I'm going to divide by the length of my pattern. Now 4 goes into 4 one time. So minus 4, that's going to be 0. 4 goes, oh, carry down the 4. 4 goes into 4 one time, which goes into 0. So what does that mean? That means 4 goes into 44 evenly. So there is no remainder. So that's the same thing as this I to the 4th. 4 goes into your exponent evenly, and that means that our answer is going to be 1. But what happens if they don't go in evenly? Let's take the next one, and we're going to take 67. We're going to divide it by 4. 4 goes into 6 one time. 1 times 4 is 4. So I subtract. You get 6 minus 4, we're going to get 7. Carry down the 7. 4 goes into 27 6 times. 4 times 6 is 24. We're going to subtract. I don't actually care how many times the pattern goes in. What I'm more concerned with is this number that we have as a remainder. That means we are going into the next pattern 3 times. So if we look at it, you are 1, 2, 3. So it's the same thing as I to the 3rd, which is really going to be negative I. And you notice there's no exponent on I because we've simplified all the way down. So one more. We have to take 102 and divide it by 4. 4 goes into 10 2 times. 4 times 2 is 8. Subtract, and we're going to have 2. Bring down the 2. 4 goes into 22 5 times. 4 times 20, or 5 is 20. Find the remainder. This is what I am concerned with. I don't care how many times the pattern goes in. That means that I to the 102 is equivalent to I to the 2nd, which means that we're really going to be negative I. Where's my thing? There it is.